In this video, we're going to see an example of when L'Hopital's rule will break down. So just a recap of L'Hopital's rule. If you're trying to find the limit of one thing over the other thing, you can simply differentiate the top. You can simply differentiate the bottom, and you trying to find the limit of this is the same as you trying to find the limit of the derivative over the other derivative, provided that the limit of this exists. So in the past, when we used L'Hopital's rule, we would just consider this bit. We didn't really look at the second part here. But by rights, you should consider the second part. So you can use this part here, provided that the limit of this thing here exists. So when I state this thing here, you won't fully understand it until you see an example. So in this video, I'm going to give you an example, and then hopefully you can see why this second part is important. Okay, so let's remember, if you're trying to find the limit of this, that's the same as you trying to find the limit of this. But just make sure that the limits here exist. So let me give you an example, and then hopefully this second part will make sense. Okay, so let's try and evaluate the limit of this as x tends to infinity. So as x tends to infinity, this thing here is just going to oscillate between 1 and -1. So as x tends to infinity, you've got this thing, and then this thing here is just going to oscillate between 1 and -1. So as x tends to infinity, collectively, this whole thing here will head towards infinity, because you've got this thing here, which will get very, very big. Let's say 99999 here. And then here you've got this thing that oscillates between 1 and -1, 1 and -1. It makes no difference to this massive number. So as x tends to infinity, this whole thing here collectively will head towards infinity. As x tends to infinity, this thing here will head towards infinity. So here you've got infinity over infinity. Then you can apply L'Hopital's rule. So L'Hopital's rule, differentiate this, that will then give you this. Differentiate this, that will then give you this. Let's simplify this. Well, something divided by 1, that's the same thing. So this whole thing here becomes this. But then the thing is, if you look at this, the limit of this thing here, doesn't exist. It does not exist. Because you've got one take away a thing that oscillates between 1 and -1, 1 and -1, and so on. The limit of this thing here doesn't exist. So you can't really apply L'Hopital's rule here. Let's go back to here. Hang on. Looking back at the original one, it's saying that if you want to find the limit of this, you can simply try and find the limit of the derivative of the two, provided that the limit of this thing here exists. But remember, provided that the limit of this thing here exists. So if you look at this thing here, the limit of this thing doesn't exist, so we can't really apply L'Hopital's rule here. So in order for us to evaluate the limit of this, we've got to use our gut instinct. So hang on. So basically, using your gut instinct, cut this up into two different fractions. So you've got this thing here over this thing here, and then now the limit of this is going to head towards 1. If you look at this, the limit of this is going to head towards, well, you've got something that oscillates between 1 and -1, 1 and -1, 1 and -1. You've got something that oscillates between 1 and -1, and then you've got this number here that's going to get very, 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 very big, because x tends to infinity. And then you've got something that oscillates between -1 and 1, -1. It makes this, well, because this thing here is going to get very, very big, the limit of this will be 0. So you've got something that heads towards 1. So the limit of this is really 1. So here, because L'Hopital's rule broke down, you just got to use your gut instinct. Find out well, here you would break it up into two different fractions. And something else you should also use your gut instinct here, because if you look at this here, you've got x plus something that oscillates between 1 and -1, 1 and -1, 1 and -1 here. You've got something that oscillates here. So if you look at this graph here, it will look something like this. it will look something like this. Um, when it will look something like this. It oscillates between 1 and -1. But as x gets bigger and bigger, this add 1 and take away 1 becomes insignificant. At first, when x is small, yes, it makes a big difference. But as x increases, when it gets very, very large, +1 -1 is not, excuse me, it's not gonna make much difference. It's heading towards the line y equals x, and then you've got this thing here, y equals x. So you can consider this thing here as x gets very, very large. You can consider this thing here as approximately x, and then you've got over x. So really, it is approaching 1. Okay, so if L'Hopital's rule breaks down, try to use your gut instinct. Okay.